Now we're going to talk about nitration of benzene. So if we take benzene, we want to put a nitro group, nitrobenzene. TNT is trinitrobenzene. We do this with nitric acid, HNO3, and sulfuric acid, H2SO4. So we know that benzene's not that reactive, and the first thing we need to do is make a good electrophile. And because the carbon atom here is attached to the nitrogen, we know the nitrogen atom needs to be the electrophile for benzene to add to. So the first thing we do is we take nitric acid, which we notice that nitric acid has a permanent separation of charge as a Zwitter ion. And we react this with sulfuric acid. And so you may want to satisfy the negative charge on the oxygen by protonating the nitric acid, but that doesn't really get us anywhere. So it's actually the oxygen that already has the hydrogen on it that is protonated by sulfuric acid. We now have the same separation of charge over the oxygen and the nitrogen, and we now have water attached to the nitrogen, which we know is a good leaving group, and the counter ion here is your sulfate. And so, as we mentioned, water is a good leaving group, so we can take the negative charge on the other oxygen, kick it down, and kick out water. So here we lose water, and we have also made NO2+. This has no resonance structures because, as written, everything has an octet, and we'd have to lose an octet on either nitrogen or oxygen to make a resonance structure, so that would not be favorable. So we can then take the pi electrons of benzene and add to the electrophilic nitrogen position. Usually when we want to satisfy a positive charge on nitrogen, we attack an atom next door. However, in this case, we want to form a nitro group in which we have the carbon of the benzene ring attached to the nitrogen. So we keep two of the double bonds of benzene. We make our NO2, which is still a Zwitter ion, and then we have a carbocation in the ring. This carbocation is resonance stabilized, so we can flip electrons around. On three different carbon atoms. So we have three different resonance structures here. What we notice is we cannot keep going because there is a proton, an sp3 hybridized carbon atom next to the final carbocation that we make. But we can have water come in, pluck off the proton to re-aromatize the ring and to make all of the carbon atoms in the ring sp2 hybridized. And that's how we nitrate benzene using nitric acid and sulfuric acid.